Okay, so I think my screen is visible. No? Now is it visible? Okay,
Yes, sir.
cool. So let's give a quick recap so that everyone will be at the same page. Let me give the quick recap first. So we had discussed about stats class 1 in class 1. Okay, hi Shashank.
Hi, sir.
Cool. You are in Bangalore? No. 1 minute. Hello. हाँ. ऑक्सफोर्ड के जस्ट अपोजिट वाला. हाँ. Okay. Okay. So let's give a quick recap what we were discussing in the last class. We had just discussed about the introductions of basic statistics in the first statistics class, and uh, we had discussed about the what are the different type of statistics are there, like descriptive statistics and inferential statistics, what is descriptive and what is inferential statistics. Then we had discussed about the data type. In the data type, we have seen like categorical data type. Categorical data type like first, second, third, these are the categorical data type. Numerical data type 1, 2, 3. This kind of data is known as the numerical data type. Then we had seen about the level of measurement. In the level of measurement, what we had discussed like qualitative and quantitative. Quantitative classification of the following two type, nominal and ordinal. In ordinal, we have seen like first, second, third. These are the ordinal data set data type it is. Then we had seen about measure of central tendency theorem and why it called as central tendency theorem. That reason I think we all know. And there are in central tendency theorem, we have seen like mean, mode, medians. And then we have discussed about how to calculate the mean, mode, median. And then we understood mean, mode, median is, and whatever terms we are learning, these terms is just because of understanding the data set, just to understand about the data set. That's what we are going to learn, this kind of terminology, mean, median, mode. Then later on, we find it out mean, mode, median is not enough sufficient to understand about the data. Am I audible, right? I'm just giving the quick recap. There is no yeah, this is not
So it's recording started.
Yeah, it is recorded. It is getting recorded. Okay. So any questions in between of this, please feel free, unmute yourself and ask. I'm just giving the recap so that everyone will be on the same page. Okay. Then we have seen like mean, median, mode is not sufficient about to understand any kind of data set. Then we had discussed about the measure of dispersion. In measure of dispersion, we have seen range, variance, standard deviations. Lot of things we have discussed. Then we had discussed about the sample and population. What is the sample? What is populations? And sample is the sub part of population. That part we have seen. And yeah. And then we have discussed about how to calculate mean, variance, and standard deviation for population, and how we are going to calculate the mean, variance, and standard deviation for sample. And what is the variance does? What is the medians? What is the variance? What is the standard deviation does? And how we are going to calculate those things, everything we have seen. Okay. And then we at the end we have discussed about the formula difference between mean, median, mode. We have seen this n and this is n minus 1, and the reason also has been given while giving the class. So yeah, this much was at the first class. And the second class, what we had discussed, let me quickly open this second class. Just a minute. Okay. Okay. So in second class, we have started from the same point where we left in the first class, measure of dispersion and range, variance, standard deviations we have discussed, and what is the importance of variance, how to calculate the variance. That part you guys only has been calculated. I think everyone knows. And any doubt so far about the standard variance calculations? And don't worry, these are the formula already available. We can go ahead with the formula directly. We no need to do these things so much better. Okay. So then we had discussed about the standard deviations and what is the standard deviation does and how to calculate the standard deviations. Okay. And the facts about the standard deviation, we have seen sample versus population. In the sample, how we are going to calculate the mean and how we are going to calculate the mean for the population, that we have seen. And then we have seen that variance, how we are going to calculate for the population, how we are going to calculate the variance for these things, population. And then we have seen about the data set. What are different type of data set is there, like symmetrical data set, asymmetrical data set. Symmetrical data set, like those data set, if we are going to divide the data set in two parts, both the parts should be identical. That is known as the symmetrical data set. And we also have discussed about this formula. This is known as the Gaussian distributions. And what it does, it helps us to draw a scatter of the data set. And you guys already drawn these things, this data, how any kind of data is following this curve, bell-shaped curve. This is known as the bell-shaped curve. And why all the data set is following this curve only, that is get derived from this formula. So that part we have discussed in our last class. Now we have discussed about the mean, mode, median. like symmetrical data set. In symmetrical data set, how you can say like its data set is symmetrical? The symmetrical data set we have seen like mean, mode, median is lie at the same point, that is known as the symmetrical data set. But if the mean, median, mode is not lie at the same point, then those kind of data set is known as the scattered data set or asymmetrical data set. Do you guys any doubt so far so forth? So this is all about the things we have discussed in our class day 2, stats day 2. Okay. So sounds like there is no doubt. Okay, cool. Okay. Okay, let's do some practical now. It's more theoretical concept we have been seen. Now let's do some practical. What do you guys say? Shall we go ahead with some practical?
Yes, sir.
Sure.
Yes, sir.
Cool. So bring your laptop, turn on your hands.
Sir, I'm outside, but I'll
Yeah,
do it
sure.
at the night.
Sure, no worries. No
Right.
worries. Okay. Do let me know if you guys can see my screen. Open your Jupyter Lab or Jupyter Notebook. Authentication failure. Okay, cool. So fine. I would like to go with download desktop. There is no desktop. Okay. Fine, no worries. I will do one thing. I'll create a set of document. I'll create a new folder. And stats day 3. Instead of this, I'll create a new Python file. Okay. So what I'm trying to say, let's suppose we have the data set. Let's suppose we have a data set equal to this. Now, for this data set, I have to calculate mean, median, mode. So first of all, tell me how we are going to calculate the mean, median, mode. Can anyone explain me how to calculate mean?
Mean is the average.
Mean is the average. So sum all those things and calculate those things. But I will not go with those things. I will go with the standard libraries which is already available, like import NumPy. NumPy is the package as NP. And I would like to go with the Spacy. Spacy is the scientific library which will help you to calculate mean, median, mode, standard deviations, variance, all the sort of things. Okay, so go with that because these libraries are already available. But you know the formula, right? Import SciPy as import SciPy from SciPy. Just a minute. From SciPy import stats. Okay, so I just imported this thing. Now if I have to calculate the median, how we can calculate? NumPy dot median is the inbuilt function it is. And now calculate the data set, pass the data set, and it will give you the median. Median, how we are going to calculate the median? Can anyone tell me? arrange the data in the ascending order, and in between of that, whatever data will come, that will be the median. Right? So if you can arrange this data in the ascending order, you will get it out. Cool. So I'm going to store these things in a median. Okay, so this is my median. Now, if I want to calculate the mode, if I want to calculate the mode, so in NumPy there is no inbuilt function which can able to calculate the mode. So for that we have to go with the stats package, and in stats packet we have the mode inbuilt function, and here you can pass your data set and it will give you the mode. Okay, so you can see the mode means whatever data is coming most frequently, that is known as the mode. So you can see in this data set 5 is coming most frequently, right? So 5 will be the mode, and that's what it's giving the mode as a 5. Can you see this? Okay, does it make sense?
Sir, what is here a count error also, sir? What
Okay,
is count error?
so I will tell you, I'll tell you these things. This is giving the array. It can be mode can be 2 or 3, right? Let's suppose 5 is coming 2 times. It can be possible 2 will also be 2 times. So in that case, this will be array. And this count is nothing but like how many times it got occurred. This 5 got occurred how many times? 2 times. That's what. Can you see this? This 2. That's what it's saying 2. This makes sense?
Yes, sir.
Yes.
Cool. So now if you want to calculate the standard deviations, can anyone tell me the formula of standard deviation? No. Anybody? What is the formula of standard deviation? Summation of, भूल गए सब कुछ. Summation of, I'm writing here, summation of xi minus x bar. X bar means it's mean, minus mean. I'm not able to write x bar, that's what I'm writing like this. Divided by what? N, yes. Oh, I made one thing mistake. Here should be the square root.
Square root.
No, first
Square root
square
of something.
and then divide by n and then whole ka square root. Yeah. SQRT. I'm writing SQRT, so just try to understand. This is the square root. This was the formula. So this was the formula you have to calculate, but if there is a inbuilt functions is already available which can help you to calculate the standard deviations. Okay, so I'm gonna use that inbuilt function np.std standard deviation std, and here you can pass your data set and you will get your standard deviation. You no need to write a complex functions in this case. It does make sense. This is our standard deviation.
मतलब सर मेरे को ज्यादा प्रॉब्लम नहीं होगा.
नहीं, I was saying you like from the day one, but you should know the formula. You should know how it came. The functions is already inbuilt. Okay. Does it make sense?
Yes.
Okay. Now standard. Okay, if I will tell you the variance, calculate the variance. How you can calculate the variance? So same formula. Np dot where, and here you can pass data set, and you can see and how it came. So just try to understand. Control C, Control V. If I will do power of 2 or else multiply with the same number, okay, you will get the same number. How it came? Because variance is the square root of the standard deviation, right? That's what this value is coming like this. Does it make sense, guys? Are you able to understand how it came? So variance is the square. Okay, let me write that. Variance is equal to SQRT. Variance is equal to standard deviation is equal to SQRT of variance, square root of variance. So variance, if I'm calculating the variance, if I have to calculate the variance, what I have to do? I have to square of this standard deviation, right? I have to square of the standard deviation, then only variance can be calculated. So what I did here, I did here standard deviation multiplied by standard deviation, and we are getting the variance. Does it make sense?
Yeah, yes, sir.
Yeah, yes, sir.
Cool. So I'm not gonna write these things here. Cool. I'm just showing you the last day we have discussed about the mathematical formula, and now we are doing everything by the Python code. Okay. So I will do one thing. We have calculated a mean. No, we not calculated a mean. So median we have, stats mode we have. I'm gonna write here mode so that it will be stored here. And we have standard deviations. We have variance, right? I'm gonna store inside of var variable. So variance we have, and now we don't have only one thing, mean, right? So mean, how we can calculate the mean? NP dot mean is the formula, and here we can pass the data set, and we are good to go. Now what I can do, print, I'm gonna write here mean, comma mean, print mode, mode, comma mode. I'm gonna write mean, median, right? So print, so everything I'm gonna write here in one go. Median, colon. Here also I'm gonna write this median, comma median. And what was else? Print standard deviation, standard deviation. Here I'm gonna write steady standard deviation, and here I'm gonna write print variance, comma variance. Now see all the result we have at the one goal. So we were struggling a lot in the last session, right, to get this result. Now we have everything. Does it make sense, guys? Any doubt?
Yeah.
Yes, sir.
Cool. So all the doubt has been cleared regarding for the central tendency theorem and measure of dispersion. Any doubt? No doubt. Okay. Now let's come on the theoretical concept. Okay, let me explain once again the theory. Let me move back to my whiteboard. Do let me know if you guys can see my screen. Okay. Are you able to see my whiteboard?
Yes, sir.
Yes, sir.
Cool. So I am gonna create new whiteboard for you guys. Just hold on. Okay. So this is the stats day 3. Okay. Just a minute. Someone is waiting for me. Okay, I'll be back, guys.
Yes, sir.
Okay. Okay. Okay, cool. So now we are going to discuss about random variable. How many of you know about this term random variable? Anybody? Anybody having any idea about the random variable?
First time I
First time you are listening. Oh, so sweet, so sweet.
I have some ideas, sir, but not sure.
Okay. So have you faced this kind of problem like coin problem? Like if you throw a coin twice, what is the probability of getting head?
Yeah, yeah, sir.
Yeah. So this kind of term we have been used in the random variable. So random variable. How many of you are in Bangalore? So, yeah, Akshaya, you are in Bangalore by default. अरे you are also in Bangalore. और अभी तू कहाँ है? कीर्तन भजन कर रहा है?
नहीं सर मैं यहाँ है वापस से ट्रेन हमारा एग्जाम अभी अभी खत्म हुआ तो अभी हम यहाँ रुका भी नहीं
Okay. Okay. Mute कर लें. And when you are coming,
कहाँ सर कहाँ है
no, I am not saying to you. You mute कर ले. Shashank, when you are coming to Bangalore?
on 20 sir 20th of November.
Supposed to come on the 1st of November.
Yeah, I changed the plan.
Okay, no worries, no worries. So random variable, if I will, okay, let me write, open this snipping tool. So if I will talk about a random variable with this diagram, so you guys can see this screen, right?
Yes, sir.
So random variable is nothing but it's a random variable is the set of all possible value from the random experiment. Let's suppose if you are throwing a coin, so what are the possible scenario may occur? Either it can be head or it can be tail, right? Either 1 or 0, right? So this possible outcome is known as the random variable. Did you understood what I said? What is the random variable?
Yes, sir.
So if I will write here about the random variable, so random variable is nothing but it's a set of all possible values from the random experiment. For any kind of random experiment, what the possible outcome? See, if you are going to give an exam, either you can crack or you can fail. You will not be in middle of the something, right? Either you will be pass or fail, right? These are only two possible outcome. But let's suppose what I can give the another example. Let's suppose a pregnant lady. There is if any lady is getting pregnant, there is only three possibility. Either the newborn baby will be boy baby, child, girl baby, or transgender. Right? This is only three possibilities are there. Right? So whatever the possible outcome, and let's suppose if you are throwing a die, you know, right? That Ludo dice, like 6 faces.
Yeah,
Die.
yes, sir. 6
So,
feet.
if you are throwing a dice, there is only possible 6 possibilities are there. Like in one, if you are throwing once, only 6 possibilities are there. Either it will be 1 or 2 or 3 or 4 or 5 or 6, right? But it cannot be 1, 2, 3, 4, 5, 6. Everything will come at the same time, right? Only one thing can be possible, and all the events is mutually exclusive. Mutually exclusive matlab means they are not dependent to each other. like if one is coming, then there is a other r will not come, like 2 3 4 5 6 will not come. If phase 6 is coming, then 5 4 3 2 1 will not occur. This is known as the random experiment. Okay, and random variable are those variable is a set of possible values from the random experiment. For any kind of random experiment, what are the set of possible values you can predict, that is going to consider as a random variable. Does it make sense, guys? Any questions so far so forth? No question. Okay, so let's suppose I'm going to give you one scenario. Okay, so two-person is tossing. Let's suppose Akshaya and Sasank, two-person having the one coin. You also have coin, and Sasank, you also have coin. So what are the possible outcome may occur? Two coin you are throwing simultaneously.
Two head, two tile, one head, one tile, or one tile, one head.
Let me write. So let's suppose this is Sasank and this is Akshaya, and these two guys are going to toss. Then what are the possible outcome may occur? It can be either both are head. It can be possible head or tail. It can be possible tail or head, or it can be possible tail and tail. Does it make sense? Anything else you can understand? You can predict like anything other scenario might occur?
No, sir.
No. समझ में आया क्या नाम है इसका शशांक? And then this variable is known as the random variable. This variable is known as the random variable. Okay, cool. Now we are good. Okay. Now we are going to discuss about, there is a different type of random variable are there. One is discrete random variable. Discrete random variable is what? Let's me talk about the discrete random variable. Okay. So discrete random variable is one that may take on only a countable number of discrete value. And what do you mean by the discrete and continuous number? What is the difference between discrete and continuous? I think I have discussed these things in our last classes. Yes or no? Yes. What is the discrete number? What is the continuous number? And what are the difference between these? No answer. Very good. Let me explain once again. Okay, so if I will talk about discrete number, the number which is getting defined at certain instant of time, like 0, 1, 2, 3, these are the discrete numbers and so on. But if it is a continuous number, then it's like a, at every point some values are there. Every point some values are there. Some values are there. Some values are there. Some values are there. Every point there is every point there is some values are there. This is known as the continuous number. Does it make sense, guys? Continuous number. Continuous number can be anything. 1.01, 1.02, 1 point like this, blah 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 blah, and so on. Okay. Now, no one should ask these things. What is the discrete number? What is the continuous number? Any question? Any question? Discrete number and continuous number?
एक बार और बताना सर.
Okay, discrete number are those number which is getting defined at a certain instant of time, like 1, 2, 3. Between 1 and 2, there is nothing. If you are going to take another example of continuous number is getting defined at every instant of time. See, 1.01, 1.02, 0001, 00002. If I'll ask how many numbers are falling between 1 and 2, can anyone tell me how many number is falling in between 1 to 2?
Infinite, sir.
Infinite, exactly. Like 1, then 1.01, then 1.0001 kind of thing, right? So it will be infinite number. But if I'll talk about how many discrete number is falling between 1 to 2, no, there is no discrete number falling between 1 to 2. But continuous number is falling infinitely. Okay, so discrete random variable. So I'm talking about the discrete random variable. So let me write that first definition, then I will talk about these things. So discrete random variable. So discrete random variable is one that may take on only a countable number of discrete value. Discrete value, you know, like 1, 2, 3. If the random variable can take only the finite number of discrete value, then it must be discrete random variable. Means it's not like that infinite number will fall. It will be a discrete value. I mean, it will be a finite value. Okay. Example of discrete random variable is what you can take. I will try to write. So let me give some example of discrete random variable. So are you guys making notes, your own notes, or you are following my notes only?
Only your notes.
So थोड़ा सा मेहनत नहीं करेगा? नहीं करेगा?
From here and there,
क्या बोल रहे? वही.
like even this also referring and by own searching also.
ठीक है, very good. Okay, that I will see. And then
I follow only you, sir.
Very good. Okay. Example of discrete random variable. क्या क्या हो सकता है बता पाओगे? Any example you guys can follow me? Any example? Can you give me, guys, of discrete random variable? I think you guys have the lot of idea about the discrete number now. अरे कुछ भी बोल दे. Example of children. Number of children in a family. कभी ऐसा देखा है 1.5 चाइल्ड है मेरे पास, एक और एक आधा बच्चा, ऐसा कभी हुआ है? हेलो, मैंने कुछ गलत बोल दिया क्या? ओके. नंबर ऑफ चिल्ड्रन इन द फैमिली. और कोई एग्जांपल? एनी मोर एग्जांपल? See, you have to think about these things now. कुछ भी एग्जांपल बताओ यार.
नंबर ऑफ आधार कार्ड सर.
नंबर ऑफ आधार कार्ड. हाँ चलो मान लिया, सही है. नंबर ऑफ आधार कार्ड. चलो सोच तो रहा है कुछ. सोचोगे नहीं, जब तक बोलोगे नहीं तब तक होगा नहीं. टू बी ऑनेस्ट, यू हैव टू स्पीक. फर्स्ट रूल मेकिंग कॉन्फिडेंस दैट you have to
sir ये how is possible number of patients in doctor surgery?
या ऐसा कभी हुआ है डॉक्टर ने आधा सर्जरी किया है? पूरा सर्जरी करता है. कितने पेशेंट का सर्जरी किया है? द नंबर ऑफ पेशेंट इन अ डॉक्टर सर्जरी.
मेरे हॉस्पिटल में सर एट अ टाइम 10 का हुआ है.
अच्छा, तेरा हॉस्पिटल भी है?
हाँ सर.
स्कूल भी है, हॉस्पिटल भी है?
यस.
दोनों में तेरे को भर्ती कराना होगा फिर तक. चलो ठीक है. Okay, so fine. I think you guys understood about this discrete random variable and discrete number. Now no question should be arise. Make sense? Any questions?
No
Yes.
sir.
No, sir.
Okay, cool. That makes sense. That makes sense. Okay. So first rule, I was talking from the very first day, and I used to speak about these things in my many conferences. Like people has to speak. If I'm giving any mentor, it's not like me. Any mentors is trying to teach you something. You have to speak. You have to ask the question. You have to open your mind. You have to open your mouth. Otherwise, nothing will go inside. सब चीज बंद रखोगे तो कहां से अंदर जाएगा? दिमाग का कोई खुला हुआ दरवाजा नहीं है. There is only way from where the things will go inside. That is your mouth. You have to speak. जितना ज्यादा पूछोगे, जितना ज्यादा बोलोगे, उतना ज्यादा गेन करोगे. Okay. Now I think, okay. Now I'm going to ask about the probability distributions of discrete value. Okay. So let me write these things. Okay, so I would like to tell you one scenario. So let's suppose if we are tossing a coin, then there is only two possibility of this coin, right? Like if you are throwing a coin, there is only two possibility. Either the coin face will be head or the coin face will be tail, right? So what is the probability of coming head? What is the probability of coming tail? Can anyone tell me? Probability means संभावनाएं.
50-50 sir.
50-50 exactly. 1/2, 1/2. Now let's suppose if there is a die. Die you know right? Ludo वाला die, 6 face वाला. मेरा ड्राइंग बहुत अच्छा है, समझ जाओ. ये 6 फेस वाला डाई है, ठीक है. 1 2 3 4 5 6. सो इसमें 1 2 3 4 5 and 6. What is the probability of coming each face in a die?
Same sir.
Same. Same. Means 50-50. 50-50?
Every face has a chance. No, sir.
Every faces has a chance, like 1/6. How many faces are there? This possibility of coming 2 is 1/6. 3 आने का third number आने 1/6. Fourth 1/6. Fifth 1/6. Sixth 1/6. These are the possibility, right? Similarly, if I will tell you 2 coin you are throwing, like Akshay and Sanka is throwing each coin by itself. So then the possibility of coming head is 1, head tail is 1, tail head is 1, and tail is 1. Now tell me the probability of coming each of this random variable. So 1/4, this is 1/4, 1/4, 1/4, 1/4. Does it make sense, guys? And if you will add all those things, it will be always be 1. Can you add this? Yes. So this is the thumb rule of probability. The probability of each note. There is a note. So let me write the note. The probability, the summation of, sorry, my bad, wait.
राइटिंग सर मेरे घर वाले अच्छे से समझेंगे, मैं कंफ्यूज हो जाता हूँ कभी कभी क्या लिखा है.
अच्छा, तेरे घर में सब डॉक्टर है क्या? मतलब तू मेरी इज्जत दे रहा है, बेइज्जती कर रहा है मेरा?
अरे नहीं सर.
अरे भाई, डिजिटल बोर्ड पे लिखना इट्स वेरी वेरी हार्ड टू मेक योर हैंड, बट या आई एम ट्राइंग.
वो तो आप तो टच पैड यूज करते हो ना सर?
हाँ, टच पैड यूज नहीं, टच पैड नहीं मेरे पास. ये है, दिखाता हूँ. I have this one. Okay, how many of you are able to see? This is the digital board. So here I'm writing by this pen. This is called the pen tab, actually, the name of this. Okay. If I'll write from the touchpad तो कुछ भी नहीं समझ में आता. Okay, so note the summation. तो डॉक्टर को लेके बैठा कर दो. Summation of probabilities of each random variable is equal to 1. Does it make sense?
Yes sir.
So I had proved as well these things. Okay, now if I'll write here, let's suppose there is one experiment. Let's suppose there is one experiment जिसमें just suppose there is one experiment जिसमें the number of random variable, the probability of coming of number of random variable is n. Okay, now tell me the summation of each random variable. So p1 probability of 1 comma p2 dot pn. There's an nth random variable. Now if I'll sum of all those things, summation of P of I, and I is nothing but equal to 1 till n, is always equal to 1. This is the rule of probability. Did you understood this mathematical derivations? How it came?
Yes.
Can you explain, Akshay, this how it came?
The experiment part, sir.
Yeah, this experiment part. How it came,
Yeah.
the summation of P of I.
Eh,
शशांक सुनते रहना अपना.
If you add to everything, if you add also all the data, you have to get 1.
Yes, we have to, but what this, let's suppose this formula, can you derive this formula, like how it came?
P1, like if you split that one,
Yeah.
P1 plus P2.
Yes,
plus
exactly. So I ka value is getting start from 1 till n. So P1 plus P2 plus P3 plus P4 till dot 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 Pn. That's what it means. And I always be equal to 1. Okay? Makes sense?
Yeah.
Any doubt? And one more thing. So if the summation of probability of each random variable is equal to 1, then is it possible to have the probability value of any random variable is greater than 1? Yes, no. What I asked, did you understood? So let's suppose, is it possible P of 2 is greater than 1? Is it possible?
No, sir.
No. Because the summation of all those things is equal to 1, then how could it be P2 is greater than 1? Not possible at all. Okay. So very peculiar interview point of view questions. Like they must ask these things. Now we are going to discuss about, okay, we understood about the discrete random variable. Any question in the discrete random variable? I think no. Now we are going to discuss about continuous random variable. Afterwards, the machine learning classes will get start from the next day. It can be extended. So, okay, so tomorrow and day after tomorrow, there is no classes. Monday is the Diwali. When is the Diwali?
Monday, sir.
Monday or Wednesday? I don't know.
Monday, sir.
Monday. Okay, so Monday we have Diwali. I think Tuesday or Wednesday we can have our classes and we can finish this class, this statistics class by this week. So from the next week onwards, we are going to start the ML classes. ML classes will be interesting, very interesting. Complete whatever things we are going to learn, everything we have to implement there. These are the very theoretical classes. Okay. Okay. So now continuous random variable. Can anyone help me out? What is continuous number first? And then I will talk about the continuous random variable. Anything? अरे अभी तो बताया continuous number, discrete number.
0.001.
हाँ. So it is. So let me write that first. Then I can explain you better way. I'll make it something different color. Anyways, the continuous random variable, it is one that takes infinite number of possible value, right? Infinite number of possible value. Continuous random variable usually are the measurements. For example, the height of a person, the weight of a machine, the amount of sugar in a tea, etc. This is the continuous variable. Any example you can give of continuous random variable? Any example?
We can take real numbers also.
Yes, real number, but any example, real time example of continuous number, continuous random variable. अरे कुछ भी बोल दो, amount of wheat, amount of sugar. Okay, this is a continuous random variable. Okay, now we are going to discuss about another random variable, set. What do you mean by the set? Set is the data structure. A set is a data type where we are going to define the data where data will not get repeat. Did you understood? So what I am trying to say, just hold on. So let's suppose set is the collection, and in that collection, every time we are going to store those random variable which is coming as a unique 1, 2, 3, 4, dot, dot, dot. It will never be like 1, 2, 1, 4. This is not a set, but this is a set. Set is the collection of unique data type, unique data. That's all. Okay. Did you understood what I am trying to say?
Yes, sir.
Cool. So set is, let me write a definition as well. So I was talking about this. Set is well-defined collection of objects. A set that contains zero element is called null set or empty set. Okay. Let one example I would like to give. Let A and B are the two set. Let me write this. Let A and B are the two set, then A is set as a subset of B, or B is the superset of A if every element of A belongs to B. Means what I'm trying to say, just let me write one example. Let's suppose we have one set. And please interrupt me whenever you feel that it is going over your head, then feel free to let me know. Okay. So let's suppose a set it is A 1, 2, 3, 4, 5, 6. That's all. And B is the set of 3, 4, 6. Then you can see all the element of A is present inside of B. Then I can say A is the superset of B. Yes, no. Does it make sense, guys?
Yeah, yes, sir.
Okay, so same thing I have been written here. Okay, cool. Are you guys feeling sleepy? Who are feeling sleepy? Or should I continue one more hour?
Continue, sir.
Continue.
Okay, so a set, next is a set may be defined. Just a minute, I'm getting some mails back to back. I don't know what is that. So this is the same thing like I just explained this bracket. So set is going to define by this. For example, you can take this example. Yeah. Okay, now we are going to discuss about operations of set. Okay, let me write the operations of set. How many of you know operations of set? Any idea about the operations of set?
Yes, sir.
Yes.
What are the different type of operation? Sorry.
Sir, union
Yeah,
section.
union
Yeah.
intersection. तू म्यूट ही कर ले, तो अभी कीर्तन कर. Okay. Just a minute. Let me do one thing. Okay. So first operation we are going to perform union. The union of two set is defined as a set of elements that are present in one or both set. Thus, A is, for example, A is 2, 1, 2, B is 2, 3, 4. The union of A and B is what? Let's suppose what I am trying to say. Let's suppose we have one set 1, 2. We have another set 2, 3, 4. And if I will tell you the union of A and B, what will be the set? 1, 2, 3, 4. This will be done. If I will show you in the Venn diagram, this is the set A, and in this set we have 1, 2. And this is the set of B, and here is the 3 and 4. So 2, 3, 4. 2 is the common. That's what A union B will be 1, 2, 3, 4. This is our union operation. Does it make sense, guys? Any doubt?
No, sir.
Cool. Very nice. So next operations, what is that? Intersection. So let me write that part as well. Union symbol, it is this. Just a minute, let me first make it alignment first, because this is the very part. We got part. Cool. So now I'm gonna discuss about the intersection of two sets. The common element that are present in both the set are known as the intersection of two set. Let's suppose again, A is, we have A set. We have A set. In A set, we have 1, 2, 5. And we have set B. We have set Y. Okay, Y is 2, 3, 4, 5. And let's suppose if I am gonna calculate A intersection of Y, intersection symbol it is this one. A intersection Y, then common term. What is the common term is here in between of these two set? 5, right? So 5 will be this.
2 also.
2 hai? Asha, 2 भी है. Okay, sorry. So you can see with the Venn diagram as well. This is the A, and in this A we have 1, 2, 5, and this is the our B. We have B में क्या क्या है? 2 है, 3 है, 4 is also there, and 5 we have. And this is our intersection term. If I will draw this properly, and if I'm not wrong. This is our this things. Cool. So this is our A intersection B. Okay, समझ में आ रहा है शशांक?
सर ऊपर से गया
ऊपर से चला गया, इसमें क्या दिक्कत है? So we have one set 1, 2, 5 and we have another set 2, 3, 4, 5. इन दोनों सेट में कॉमन बता क्या है? कॉमन नंबर
2, 5.
So 2, 5, that's what intersection. जो बीच वाला है, जो दोनों में कॉमन है, उसको हम इंटरसेक्शन बोलते हैं. और क्या आप समझ में आया? अब अंदर से गया?
हाँ सर.
Cool, nice. Now we are going to discuss about complement. What do you mean by the complement? So complement. So let me write that part as well. इसको यहाँ पे लिखता हूँ. The complement of an event is defined as the set of the element but not in the event. Means, okay, means let's suppose we have one die. We have one die. Die में क्या क्या faces आ सकते हैं? Tell me that. 1, 2, 3, 4, 5. These are the possible faces that can occur if we are throwing a die, right? But if I will tell you the complement of the occurrence of faces of a die, then what do you mean by this? What the mean of this statement means? Those random variable will occur which is not possible to come as a face whenever we are throwing a die. So anything apart from this 1, 2, 3 means 7, it can be 8, it can be 9, blah 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 blah, infinite. It can be anything, but not 1, 2, 3, 4, 5, 6. Does it make sense? This is known as the complement. So if I will talk about the example, so let me write that. So let's suppose a sample space 0, 2, 3, 4, 8, 9 and x is 2, 4, 6. Then the complement of x is what? So what I was trying to say, this is 0, 2, 3, 4, 8, 9 and we have x equal to 2, 3, 4. Then if I will tell you the complement of x, what will be that? Remove this 2, 3, 4. Then 0, 4, 8, 9. Any doubt in this? The complement, how to calculate the complement? No doubt?
No.
Don't worry, for these also some functions are available in Python. I'm just showing you the mathematical derivation so that you guys not feel that you are in something math. You came for something and you learning something. शशांक तो सोच रहा होगा भाई ये तो मैथ पढ़ाने बैठ गए, है ना?
नहीं सर, देख के अच्छा लग रहा है।
अच्छा लग रहा है? क्या अच्छा लग रहा है? कि मैथ
सही
पढ़ रहा
1,
है?
2, 3 लिखा हुआ
1, 2, 3 तो तू नर्सरी में भर्ती हो जा, 1, 2, 3 वहां भी देखने को मिलेगा।
Sir, maths also here only basic we use or more complicated?
No, basic. It's not like that integration and differentiation.
Yeah, that's what.
It's very simple, and these are the mathematics we learned in I think 5 and 6 standard. Yes, no.
Yeah, yes.
Yeah, we are not learning any new mathematics here. It's very simple mathematics, to be honest. Just 4 to 5 class, if you can recall, it's much better. Okay. Okay. So see, we are learning those mathematics which will be helpful to understand about the data set. That's all. So these are the mathematics that are important to understand about the data set. That's all. Does it make sense, guys?
Yes.
Cool. Now we are going to discuss about skewness. What do you mean by the skewness? Shall we take a 5-minute break?
Yes sir.
Yes, sir.
Sure. So we'll continue at 9:15. Okay. So hello everyone, are we back?
Yes, sir.
Cool. So water ले गया था. Using the water. Okay. So I was talking about skewness of the data set. What do you mean by the skewness? So skewness is defined the measure of the data set symmetrically. Means if skewness is very high, then means data set is not symmetric. If skewness is low, then data set is more symmetric. If skewness is zero, then data set is completely symmetric. So what I'm trying to say, was talking about this term. Okay, so you can see this is skewness. This is skewness to left, negative skewed. So you can see this data is left side is very skewed. Are you guys able to see this?
Yeah, yes, sir.
This is called left skewed. Okay, so that's it is known as the negative skewed. So when negative skewed will be when your mean is less than mode. How I understood, you can see with this diagram. Mean is less than mode. Then it's known as left skewed data or negative skewed data. But if your mean, mode, median are equal, then your data is known as the symmetrical data. But if your mean is greater than mode, then you can say it's a right skewed data or positive skewed data. Did you understood? So mean and mode is very important factor to calculate whether the data is left skewed or right skewed or symmetric. Make sense, guys?
Yeah, yes, sir.
Cool. So let me write the definitions as well for skewness. So skewness defined as the measurement of the data set symmetry. A perfectly symmetrical data set will have zero skewness. That's the one thing. Cool. Now, how we are going to, okay, the skewness defined as, how we are going to define the skewness? Let me write that. Okay. So let me draw one diagram first. So smart. Just a minute. Just a minute. So if I'll give you one data, that suppose if I'm trying to give one data, It's a 4 crackers. Oh shit. Are you guys listening something?
Yes, sir.
क्या है?
डाटा दे रहा है
ऊंची सुनाई बढ़ा दे रहा है.
Here also they have started.
Okay, they have started. Okay, I never seen the Diwali in Karnataka. I saw once in my life, but yeah, it was nice. But if you guys have seen North Indian how they are celebrating Diwali, then you will forget the South Indian Diwali. To be honest, they are very prone towards the Diwali.
Yeah, there it is different. No, sir.
Yeah.
lots of research and experiment on crackers.
Okay. Anyways, so guys, are you able to calculate the mean median mode for this data? Quickly, you have the Python code, or else you can calculate by mathematics as well, as you wish.
Both, sir.
So please calculate it, mean median mode. Calculate the mean median mode. It's very simple mathematical formula. And tell me the answer. Anybody is calculating?
Yeah, yes, sir.
Yes, sir. Mean 4.4.
Okay, I can trust on you. Shall I trust on you?
50, sir.
अभी भी 50-50 है.
Yeah, correct, sir. 4.42.
Oh, hi. 4.42. Okay. And mode is 2. Mode is 2.
Median is 5.
And median is 5. Nice. Or now tell me it's a left skewed, right skewed, or symmetrical data set by above diagram.
Mode is less. It is positive.
So mode is less than median. So it's a
Yeah.
positive skewed data. So it's following under this criteria. So now you understood with the data set, you can say it's a positive skewed or negative skewed or symmetrical data set. Yes, no.
Yeah, yes, sir.
That's my question. Okay. Fine. Now there is a one more concept is that PDF. Probability distributions functions. Had your dinner, guys?
No, sir.
Yes, sir.
You had done Akshay?
Yeah, before class only.
Oh, nice, cool. Means you are ready to take another 3 hours class.
Yeah, yes.
Good. I'm kidding.
Don't know when it will end, so I
Okay. So probability distributions functions. Probability distributions is the mathematical function. Okay, what do you mean? Have you heard about this term PDF?
PDF have heard, but this
PDF वो वाला PDF नहीं, document वाला PDF नहीं. It's a mathematical term.
एक और PDF में
probability
सुना।
was-
हाँ?
One more PDF post doctoral fellow.
रख भाई तू अपने पास.
probability I have heard, sir, but density function.
Okay, no worries. So let me give the answer. So probability distribution. The probability distribution function is the mathematical function through which the probability of occurrence of different possible outcome in an experiment can be calculated. So this is the probability distribution function. What I said, probability distribution function is a function which help us to calculate the probability of occurrence of different possible outcomes in an experiment. This is known as the probability distribution function. So what I said, let me write that. This is the function probability distribution function is the function through which we are able to calculate, the probability of occurrence of different possible outcome in an experiment. If the probability of an event is higher, it more likely that event will occur. Means if the probability of an event is higher, then it more likely that the event will occur. For example, this is very important, and here I am gonna take more, means like another 1 or 2 hour classes. So for example, let's suppose I'll take an example. If while tossing a fair and unbiased coin, let me write that. So while tossing a fair unbiased means like it not like that. If you are tossing a coin, it can stuck in between of head and tail. This is known as the unbiased. Okay. Of tossing a fair means like unbiased coin. There could be a chance possibility of two outcome, either heads or tails, which are equally probable. 50-50% chances are there. So now the probability of getting head and tail is 50%, right? The probability of getting head and tail is 50-50. That's all. So now, type of probability distributions function, there is a different type of probability distribution functions are there. So number one, because see, there are many different type of probability distribution functions are there. Some of them which are the which will we cover the means like lot of things. First thing is that normal distributions probability distribution function, normal distributions. Second, Bernoulli distributions. I will talk about these things. Second is Bernoulli distributions. Third is binomial distributions. Third is binomial distributions. Third is binomial distribution. Fourth is uniform distribution. Fourth is uniform distributions. Okay. And fifth one is student T distribution. I will talk about these things, don't worry. It deserves a separate class. Student T distributions. Third, next is Poisson distribution. जहर मत समझ लेना कि जहर समझ के नहीं पढ़ेंगे. Poisson distribution. Okay, so these are the different type of probability distributions functions are there which help us to derive the probability of coming outcomes in a different mode. Okay, so we'll talk all those probability distributions function one by one in a coming sessions. Okay, so let's suppose so let's discuss about all the probability distribution function one by one, and then we'll talk about these things. Okay, Now we are going to discuss about first probability distribution function is binomial distribution. Okay, I'll talk about the normal distributions in the coming session, but whatever is the simple and easiest that I'm gonna explain one by one. So first I'm going to explain binomial distribution. What do you mean by the binomial distribution? Binomial distribution, as its name is suggesting something, it is going to help us to get the probability of binary type of outcome, like either head or tail, pass or fail, success or failure, true, false, this kind of thing. So the binomial distribution is used when there is more than one outcome of a trial, and this outcome is labeled as success, failure, true, false. Here the probability of both outcome is the same all the trials, like head and tail. If you are tossing a coin, if you are throwing a coin, the possibility of coming head and tail is the 50-50%, right? So that's what is known as the binomial. This kind of experiment, wherever this kind of experiment is occurring, there you can apply the binomial distributions. Did you make sense? Does it make sense, guys? When we should apply the binomial distributions, the binomial distributions function we should apply on those conditions where the possibility of outcome is 50-50%. Any question?
No.
Cool. So I'm gonna write this same thing. So what I am telling, I'm gonna write this thing. Cool. So fine. So here the probability of coming the all the trial is same. That's the first point you should keep in your mind. So this is the one of the keynotes you can consider as a keynote. We should apply before applying the binomial distribution. You have to keep this thing as a keynote. Cool. And each trial is the independent, and the parameters of the binomial distribution are P and N, where P is the probability of success of the individual trial and N is the total number of trials. So here is the each trial is the independent, and the parameter of the binomial distributions are P and N, where P is the probability of success in the individual trial and N is the total number of the trial. Okay. So binomial distributions formula, if I'm trying to explain about the binomial distribution formula, then wait a minute, let me take the screenshot first. So we are going to calculate the binomial distribution formula by this formula. Okay, so let me explain about these things. Just I'll take some time to explain about this binomial distribution. So how we are going to define the binomial distributions? See, here is the possibility is same, right? So that's what, like here N is the number events.
Sir, zoom it little bit, sir.
Zoom it little bit. Okay. Okay, or else I will remove this diagram because this diagram itself is not sufficient. I'm removing this diagram, guys. I'll write it on my end. So what is the formula of, so let me write that, P of probability of N by small n by capital N equal to capital N by small n. I will talk about this term, don't worry. Bracket P of N Q of N minus N, capital N minus small n. Okay, and if I am gonna write these things in different format, is equal to n factorial. This is the factorial divided by small n ka factorial and capital N minus small n factorial and into P of n into 1 minus P of n minus n. This is the binomial distribution formula where capital N by small n is binomial coefficient. This I will tell you how to get the binomial coefficient. There is a table, binomial coefficient. Binomial coefficient and P and Q refers to success and failure. Means like success and failure, like head and tail. Anything, any binomial, like pass or fail. Failure respectively. That's all. Now P of small p capital N by small n gives the discrete probability obtaining n success. I will talk about these things, don't worry. N success. Let me write first. N success out of capital N trials. Okay. So what I was trying to say, let's suppose I would like to talk about one example question. So let's suppose one example I'm taking here. So let's suppose consider example. This is the question. Please consider this example. When hospital record, take the hospital again, shows that a patient suffering from the specific disease is 75% die of it. Means, let's suppose in a hospital, a patient is suffering from the specific disease, then there is a 70% chance he or she will get die. Then what is the possibility or probability that of the 6 random selected patient, 4 will be recovered? Did you understood this question? How many of you understood this question? Tell me. So if I'll talk about in that term, COVID term, let's suppose whoever is getting admitted, there is a 70% chance is there that patient will not survive. Then if I'm selecting 6 random patients from that hospital, then what is the probability 4 will get recovered? Now, did you understood this question?
Yes, sir.
Okay.
Yes.
Cool. So now this kind of problem, if you are getting, then this can be solved by the binomial distribution. Okay. This is the binomial distribution because reason is that there is only 2 outcomes. Either 4 will get survive or 4 will not survive. Either 4 will get recovered or 4 will not get recovered. So that's what it's a binomial distribution problem. Did you understood how to crack this is a binomial distribution problem or not? Make sense, guys?
Yes, sir.
Yeah,
Okay.
yes, sir.
Now, just a minute. Now, let's do this things. So I'm trying to solve it. Let x is equal to number of patient who recovered. तो लोग का मैथ स्ट्रांग हो जाएगा यहाँ पे. If you guys will, I'm telling you to be honest, if you guys will be like bit put your effort, your maths will be recovered. Don't worry. Here is what is given. N is equal to 6. Means how many patients we have to pick? So number of sample we have to pick 6, and out of that how many we have to get recovered? Like 4. So
4.
x is equal to 4. So two things is given here. Now probability of success is what? 75% is getting die. So success is what? Success percentage is what? So probability of getting survive is what? 25%.
25.
75% probability is getting die. Then what is the probability of getting not die? This is a 25%. So probability of success, if I can write probability of success, sorry, is equal to 0.25, right? 0.25, that is success, that is they live. Okay, so now Q is what? Q is the P is success, then Q is failure. So failure is what? How many percentage is that for failure? Bolo. Yes, tell me. What is the percentage?
75, sir.
Correct. 75%. So 0.75 is the fail. बोलते रहो तभी होगा. That is, they won't leave. Okay. Now, they won't leave, right? So now the probability, now the correct question, coming to that point. Now the probability that 4 will get recovered, that 4 will get recovered, P of x is equal to C. I will tell you what is that. X of small n, P of x, Q of n minus x. Now, C is combination actually. C is combination. C of 6 of 4, probability of x, P. P is what? 0.25. Yes, no. And x is what? 4. And Q is what? 0.75. And n minus x. N is what? 6. And x is what? 4. And if I will write here C 6 by 4 and 0.25 ka 4 into 0.75 ka whole square. Yes or no?
Yeah, yes, sir.
Now C, how we are going to calculate the C, these things, combination of this. So we are going to calculate by this formula. Wait, it's a combination actually. Just a minute. So we are going to calculate like this formula. So let me write that. Where is that? Just hold on, guys. Just hold on. Let me make it drawing first, so I can explain you. So here I'm gonna write drawing for it. This is the formula. So here I wrote like this. You can write like this as well. So this is the formula to calculate. If I will tell you to calculate C of 6, 4, then the formula is 6 factorial divided by, they calculate with R, but in our case 4. So R is what? 4. So 4 ka factorial into n minus R. N minus R means 6 minus 4 is equal to 2 ka factorial. Now, factorial means, you know, guys, right? What do you mean by the factorial? If I'm writing 6 factorial means 6 into 5 into 4 into 3 into 2 into 1, right? If I'm writing 5 factorial, then 5, 4, 3, 2, 1. If I'm writing 100, 199 into 98 into 97 and so on. Does it make sense, guys? So,
Yes, sir.
so if I'm writing 6 factorial, then how I can write 6 into 5 into 4 into 3 into 2 into 1. Then I can write, instead of that, I can write this 4 factorial. Yes or no? This.
Yes, sir.
Yeah. 4 factorial into 2 ka factorial. And this 4 factorial got cancelled. And 2 ka factorial will be 2 only, because 2 into 1 is 2. So the value will be 6 into 5 divided by 2 ka factorial is 2. And 2 3 is 6 and 5 3 is 15. So this value will be 15 into, calculate this, 0.25 ka power 4.
0.220021.
Point
219, sir.
219. Okay. So wait a minute. It seems like 244. So I'll write this. 219. Okay. Into 0.75 ka whole square.
No, sir, that together only I have calculated.
Sorry.
0.27 whole, 0.25 whole power of 4 into 0.75 square I have made.
Okay, you calculated complete thing. That's good.
Yes.
Okay. And multiply by with 15.
It's 0.0329.
Okay. Point
0
3
329.
Then the cost, if you can multiply by 100, because we have to calculate the percentage, then what is that? 3.29% is chance is there that 4% will get survive. Does it make sense, guys? What is the probability that if I'll pick 6 patients from that randomly from that hospital, then the probability of 4 will get survive is very less, 3.29%. Any doubt?
इसको 2-4 बार देखूंगा तो चला जाएगा।
अब इसमें क्या देखना है? मैथमेटिक्स. Okay,
ये फॉर्मूला समझ में आ गया सर.
Okay, Akshay, did you understood, like, is it something like very complex mathematics?
No, sir.
Okay, so I'm giving you one question. You have to solve now.
Oh, okay.
So this formula is very important. You can keep these things in your mind. Even I forgot today. These are the things we are not using in the practical life, but yeah, for the teaching purpose, I have to use.
Yes, sir. What is C, sir?
What is C? C is the combination, permutation combination. Did you learn permutation combination term in mathematics?
School days we had.
हाँ
School days we had. Sir.
या तो उसने मुझे लग रहा है तू स्कूल भी नहीं पढ़ा है ना, सही बता।
Own school was.
No, sir. Math class.
बहुत समस्या है। Okay, a die is rolled 3 times. What is the probability? Number 1. I am asking one question. Okay, this is a chocolate problem. Who can solve? Number 1, no fives turning up. No fives turning up. पहले क्वेश्चन बोलो, कितने लोगों ने समझा है?
समझ गया सर।
हाँ, एक डाई को 3 बार किया जा रहा है, मींस पहले तो ये बताओ कितने सारे पॉसिबल आउटकम आएंगे, पहले ये बताओ।
6 phases, no sir. So
Yeah.
possibility are 6.
No, wrong. 3 times.
3 possibilities. Right. No?
Think about that. Think about that. Think about it.
Any particular number, sir, or anything between 1 to 6?
Simple. एक बार डाई करते तो कितना पॉसिबल आउटकम आ सकता है? टेल मी।
एक।
6 1 2 3 4 5 6. These are the possible outcome, right? So similarly, if you take the head tail concept, right? So head tail concept में 3 time if you are doing these things, it can be possible head head head. It can be possible head head tail. It can be possible head head tail. Let me write that. Like head tail head tail head tail. 4 हुआ, 5 हुआ, 6 हुआ, 7 8 head tail, and I have a logic. That's what I'm writing. You guys can also understand these things. Head tail, and then 4 times head tail tail. These are the possible outcome. If you are going to make a 8 possible outcome can arise. Like if you are tossing a coin 3 times, then 8 possible. How? Because 1 time if you are tossing, then 2 outcome is possible. Then if you are going to toss 3 times, then 2 ka power 3. That's what 8. 2 ka power 3 is equal to 8. So similarly, we have a 6 outcome. Then tell me 6 outcome 3 times. Yani 6 ka power 3. Whatever it is, that will be. So for simplicity, I am making it as a 2. Now calculate. It's on you guys. 36 outcome will be occur here. And how? We have just seen. I'm giving you 5 minutes. पहले ये बता, क्वेश्चन समझ में आया?
यहाँ पे मैं कंफ्यूज हो गया सर, ये 36 कैसे?
Okay.
एट अ टाइम एक ही फेस आएगा ना डाई का ऊपर?
एक ही फेस आएगा, बट 3 बार कर रहे हो ना दोस्त, तो या तो एक डाई के ऊपर 1 आएगा, दूसरे डाई के ऊपर हो सकता है 2 आए, तीसरे डाई के ऊपर हो सकता है फिर से 2 आ जाए, तो 3 करके कॉम्बिनेशन बनेगा ना। डिड यू अंडरस्टूड नाउ? तो इस तरह से 36 कॉम्बिनेशन बनेंगे। सॉरी, अब हम 2 बार डाई कर रहे हैं ना, लाइक 2। नाउ 36 कॉम्बिनेशन विल बी occur. समझ में आया? हेलो, अच्छा ये समझ में आया? पहले ये बता, ये वाला समझ में आया? डिड यू गाइस अंडरस्टूड दिस टर्म? तो इसमें क्या प्रॉब्लम है? इसमें नहीं पूछा कि 8 क्यों आया सर, यहाँ पे क्यों नहीं पूछा? इसमें भी तो आना एक ही चाहिए, हेड या टेल। 8 क्यों आएगा?
जब 3 बार कर रहे हैं तो चेंज हो गया।
हाँ, तीन कॉइन को टॉस किया जा रहा है ना। तीनों कॉइन में अलग अलग आएंगे, एक ही आ रहा है, या तो हेड या तो टेल, पर 3 कॉइन है इसीलिए 3 बार आएंगे।
ओके,
हाँ, अब बताओ।
यहाँ पे हम एक साथ 2 डाई फेंक रहे हैं, राइट?
हाँ, 2 डाई।
No.
यस 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 यस, यू आर करेक्ट, टू डाई। सो आई विल हेल्प यू आउट, वेट। सो इट कैन बी पॉसिबल 1 1 1 1 1 2 1 3। प्लीज करेक्ट मी इफ आई एम रॉन्ग, ओके। 1 3 1 4 1 5 एंड 1 6 होगा। सिमिलरली 2 1 हो सकता है, 2 2 हो सकता है, 2
Yes,
3।
sir.
अब समझ में आ रहा है, कुछ कुछ घुस रहा है अंदर।
थोड़ा थोड़ा आ रहा है सर, ये शकुनी मामा वाला मैथ है सर, डाई।
सपनी वाला 3 3 but these are the very important concept, guys. 3 4 3 5 and 3 6, 4 1 4 2 4 3 4 4 4 5 4 6, 5 1 5 2 5 3 5 4 5 5 5 6। पेन एंड नोटबुक लेके बैठ, तभी होगा। मेरा देखेगा तो कुछ नहीं समझ में आएगा। समझ में आएगा तो पेन एंड कॉपी तो लेके ही बैठना होगा ना, मैथ्स का क्लास है भाई। सिमिलरली 6 1 6 2 6 3 6 4 6 5 एंड 6 6। अब देख ले, काउंट कर ले 36 आया कि नहीं। आर यू गाइस एबल टू काउंट? देखो, पहला रो में 6 and 6 row we have, total 36 outcome is there. Now the question is on you. So question was here, a die is rolled 2 times, what is the probability of no 5 turning? So how many cases are there where 5 is not occurring? So no 5, like number 1 case. अरे भाई, wait. So number 1 case, let me give that different. Okay, let me write a different. So number 1 case, 2 case, 3 case, where no 5 is there. 4 5 6 7 8 9 10 11 12 13 14, there is no 5. Are you guys understanding what is that question? Hello?
Yeah, yes, sir.
Cool. So I think now you guys can answer these things. Okay, you have outcomes, you have questions, you have everything. Apply the binomial distribution formula. I would like to know with you guys by today end of the night, or tomorrow in before morning end of the day. So please take this question, I'll pass it out. You have everything, just think about that, because if I'll give the solution, you will not make your mind here. So I'm keeping this open, so please solve these things. Does it make sense?
Yes, sir.
हाँ, इतना धीरे नहीं, ठीक है? Okay, fine. So for today, this much is only. We'll talk about tomorrow and day after tomorrow. There will be no class. So next week day, I'm planning to schedule 1 class, so we can think around that. We'll try to complete the statistics part at least before it's like ML class is starting, or else we can.
Statistics is less, sir.
Uh,
Statistics syllabus is less, sir.
this is the statistics only, whatever
Yeah.
we are learning.
Still we have.
Yeah, still 1 or 2 classes. Yeah. Why you are not liking statistics class?
No, sir, everything theory.
Yeah. Sure.
Yes, sir. Happy Dhanteras in advance.
Sure.
Yeah, happy Diwali, sir.
Thank you.
You won't burst crackers.
Huh? No, I'm not.
Crackers.
I afraid a lot. Cool. Cool guys. Thank you.